My name is Colin Bryce. I represent a company called Commscope. Just as a quick way of introduction, Commscope is a US-based company, and we're involved both really on the physical layer infrastructure for networks, both on the wireless side, on the fiber side, and on the enterprise side. So we really are at this configuration of fixed, mobile, and services, and how to deliver services to a wide area network. So as you can imagine, over the past year or so, part of my role, I've been asked both by customers and by our management and strategists what we think is going to happen in terms of 5G from a wireless perspective, but also from a network perspective. And I think we're all aware of the three legs of the stool that everybody talks about for 5G. So it's higher data rates, or the enhanced mobile broadband, and we're looking at 20 gigabits per second peak rates from a cell. The Internet of Things, and this is about the number and the density of devices that will be served, so over 1 million devices per square kilometre. And then finally, these tactile, low-latency services, things like controlling computers remotely, remote medicine that people talk about, things where you really need to ensure that data is delivered and received in a very, very specific and limited time domain. So all of these things are talked about. What a lot of people forget is that there was a fourth leg of the chair when the ITU defined the requirements for this generation of technology, and that was about network efficiency. It was about improving network efficiency by around 1,000 times. And we forget that at our peril, and I'll explain why in the next slide. The final point I would make, we're living through the period of marketing hype around 5G at the moment. This happens with every generation, but I think 5G is almost worse than any. Everybody's going to claim to be first. Everybody's claiming they've got the best equipment. Everybody's claiming the world's going to change because of 5G. And it reminds me of a futurologist who was a professor at MIT who made the statement that we always overestimate the impact of technology in the short term, but we always underestimate the impact of technology in the long term. So I'm very much a proponent of 5G, but I don't think it's going to change our lives in the next 2 to 3 years. But we do need to start preparing for the deployment of the networks. This is really the problem we've got as a mobile business. The traffic requirements are increasing dramatically and still are increasing almost exponentially. But revenues aren't. So customers want more data, they want better services, but they're not actually willing to pay all that more for it. So unless we define new services for 5G, we're maybe going to struggle with some of the business cases in the short term. And to counteract that, I think we need to think about cost-effective deployment. We need to think about flexible deployment, because things are going to move quickly and we're going to have to be able to deliver services, new services, quickly as customers demand it. And we also need the technology to be scalable. We don't want to be investing up front for huge capacity when that capacity may not be required for several years. So those are things that we need to think about. As I mentioned, we work across both fiber and wireless networks. And this is kind of our vision of the world in the next few years. And really, we think we're going to stop talking about mobility. We think we're going to stop talking about fiber. And we think we're going to start talking about access networks. This is really how do we deliver the final couple of kilometers of service to our customer. And that can be across a wireline. It can be delivering services to enterprises and businesses, or it will be delivered over wireless, not necessarily mobility, but over wireless. So you can see we actually believe that really 5G fixed wireless is really part of a wireline service package. But the blue lines on this represent fiber. And as you can see, apart from some legacy HFC networks, the vast majority of the transport delivery will be delivered over fiber. One of my managers has said you need a lot of wires to deliver a wireless network, and I think that's going to get even more so in the near future. This is a really busy slide, and it's giving one message, so you don't need to read it. It's basically saying that the networks will densify. I'm sure everybody's heard of Moore's law. So this is the law that says silicon chips are increasing in capacity on a monthly basis or a yearly basis. We in the wireless industry have our own law. It's called Cooper's law, named after Marty Cooper, who was considered by many to be the father of cellular telephony. And it says, let me get this right, since Marconi, if you look at voice channels on radio, or the data equivalent of those voice channels, and you look at the usable spectrum over a specific geography, then the capacity has doubled every 30 months. So every 30 months since the time of Marconi, the ability to deliver data across wireless has doubled every 30 months. Now, only three things can cause that. Additional spectrum, and if we take that as about 2 times capacity overall is delivered in that period with additional spectrum. It can be spectral efficiency, so within a given block of spectrum, we can increase the symbols, we can increase the data, or we densify. And the vast majority of that additional capacity has come from densification. More cells, more broadcast within that geographical area, giving that capacity. And that's going to continue to happen. So when we think about 5G, it is changing slightly from previous technologies. We used to talk about base stations. Then we started to talk about radio units and baseband units, where the digital processing was done in the baseband unit and the radio technology was delivered in the remote radio unit, and we could separate these. When we move to 5G, the base station is going to be split in 3 parts. What's called a central unit, a distributed unit, and a radio unit. And the operators are going to have a choice of how they deploy these. And basically, the central unit and the digital and the distributed unit form the same functions as the current baseband unit, but they can be split. And the reason for this is that around 10% of the digital processing required for a cell site can easily be centralized and can be virtualized in a central hub. So if we do that, we can take the real-time data processing and put that into the distributed unit, and we can either have that in an intermediate site, which allows some form of data aggregation and data pooling, or we can distribute it out towards the radio base station, which allows certain coordination between cell sites. So there are a lot of choices as to how an operator might deploy a 5G RAN, a 5G radio access network. And those choices do have some implications in terms of the transport capacity that's needed to deliver the data back to the central unit. So we're looking at networks and trying to figure out what type of architectures for the RAN are needed with different types of transport architecture. And this graph quite simply shows you can have a network which is unconstrained fiber. So basically you have all the fiber you need and you have it where you want it, or you can have a very limited access to fiber, and you can move towards a distributed RAN, or you can move towards a centralized RAN. And depending on those choices, there is the possibility of using dedicated fiber. And remember that a 5G base station is going to require between 10 and 100 times more data capacity than a 4G base station, depending on how much spectrum and how you use, for example, massive MIMO with multiple layers of technology. So these choices have to be made. And in some cases, we are definitely going to be looking at dedicated fiber to major macro hub sites. But we do have options to use WDM, to use Ethernet connectivity, to use passive optical networks, and maybe even in some limited case to use DOCSIS over copper to deliver the transport capacity back to these cell sites. I'm just aware of time, so I'll also point out that every time you deploy a cell site, the technology is wonderful, but the real restrictions come from non-technological issues, and a lot of the costs are driven by non-technological issues. Every time you deploy a cell site, you need to power that cell site. That means you've got to have a communication with the utility company, you've got to make sure that there's power at the site. You need to backhaul, which we're talking about with the fiber, but you also have a lot of issues around site acquisition and zoning. So all of these particular problems we need as an industry to solve, and we need the political support to solve these issues if we're going to be able to deploy 5G in the way in which we're hoping to. I'll just talk real quickly. One option is using coarse WDM systems to deliver services, and we think this will be used a lot in dense urban networks, simply because you can support the 5G infrastructure over the same networks that you're putting in place to deliver fiber to the home or to deliver fiber to the business. And we're working on making our products much more flexible, much more easy to use. Obviously, if we still need to splice fiber in those networks, it's going to be difficult to find the skilled labor to do that. So things like hardened connectors, things like flexibility and ease of use in terms of the distribution hubs, all of these things are going to become critical to the network deployment. I'll jump over these quickly in the interest of time. One final point I would like to make, I mentioned power. Making sure that you have the utility company turn up to every base station. If they require a meter in some markets, there's a legal obligation that where they have a distribution hub for electricity, or they have to have a power meter. All of that costs money, it takes time, it makes life difficult. We're also working on technology which allows us to distribute power along with the fiber. So if you're digging up a street and putting ducting in to lay fiber to a cell site or out to the network, we can actually deliver a DC power capability along with that fiber. And so 1 dig of the street not only gives you your transmission backhaul, but it can also deliver the power capability to power small cell sites as well. And this, we think, is an interesting technology for the future. So just to wrap up, we believe fiber is going to be the most ubiquitous transport mechanism for 5G base stations. We believe it can be integrated with the standard distribution access fiber network. But we think, as an industry, we need to be thinking about densification, virtualization of both networks, the wired and the wireless. We need to think about ensuring that the infrastructure can change easily and is highly flexible, because we don't know what services and in what capacity we're going to need those services. And we think speed and ease of access and ensuring that the skill levels do not need to be too high to deploy these networks is going to be core to what we need to do. Okay, thank you very much.